We're going to factor polynomials in this lesson. We need to remember back to when we learned how to multiply polynomials. For example, if we have these two binomials and we want to multiply them together, x times x gives us x squared, x times 1 gives us x, negative 6 times x is negative 6x, and negative 6 times 1 is negative 6. Now when we combine our like terms, x and negative 6x, we get this negative 5x. So when we multiplied these two binomials, we ended up with this trinomial. In factoring, you want to do that backwards. You want to start with the polynomial and take it backwards to where it was in factored form, or a list of things multiplied together. So we're going to be unmultiplying some polynomials. I know that's not a word, but I like to use it. So whenever you are factoring polynomials, you must follow some very specific steps. The very first thing that you should always do is factor out the greatest common factor. Look at this first one. If you look at 2x and this negative 6, you can see that they both have a 2 in common. So we can factor a 2 out. Well, what did you multiply by 2 to get 2x? You multiplied by x. What did you multiply by 2 to get negative 6? You multiplied by negative 3. Now this is completely factored. We can double check our answer though. 2 times x is 2x. 2 times negative 3 is negative 6. The greatest common factor in this case is the 2. The GCF is just 2. So what is the GCF in number 2? Well, they don't have a 2 in common, but they do both have an x. So we can factor an x out. Let's see what happens. What do you multiply by x to get 2x? Well, you need a 2. What do you multiply by x to get a negative x squared? You need a negative x. And double check. X times 2 is 2x. X times negative x is negative x squared. The GCF in this case is just x. How about this one? They don't all have a 2 in common because this one doesn't have a 2. However, they do all have an x in common. So let's factor out an x again. You multiply x times 2 to get 2x. You multiply x times negative x to get negative x squared. And you multiply x times a positive 6x squared to get 6x cubed. Double check. X times 2 is 2x. X times negative x is negative x squared. X times 6x squared is 6x cubed. The GCF, again, is x. So what is the GCF in number 4? The GCF, they both have a 2 and they both have an x. So the GCF this time is 2x. That goes on the outside. What do you multiply by 2x to get 2x? You multiply it by 1. What do you multiply by 2x to get 4x squared? Or the negative 4x squared? We multiply it by a negative 2x. Let's double check. 2x times 1 is 2x. 2x times 2x is 4x squared. So look at number 5 then. What would the GCF for number 5 be? This one's a little bit different. We have this piece we're going to look at and this piece, right? Since these are multiplied together and these are multiplied together, we're going to call this whole thing a term for now, even though you do have more terms if you were to distribute those pieces. So here we have an x minus 1 in common, so your GCF is actually x minus 1. Well, just like up here we set our GCF out front, let's set our GCF out front. What do you multiply by x minus 1 to get 3 times x minus 1? You multiply it by 3. What do you multiply by x minus 1 to get that 4x times x minus 1? You multiply it by 4x. Now in this one, if you wanted to check it, you would do it this way. x minus 1 times 3, that's this one. X minus 1 times 4x, that's this one. So now we have factored this crazy looking problem. How about number 6? They don't both have an x, but they do both have a 2. So our GCF in this case is 2. Put it out front. 2 times what is 4x? 2 times 2x. 2 times what is negative 2? That'd be a negative 1. Double check. 2 times 2x is 4x, and 2 times negative 1 is negative 2. Finally, number 7. They don't both have an x. They do both have a 1, but if you were to factor out a 1, you would just get 4x minus 1. That doesn't mean anything to us. So in this case, the GCF is 1. However, this is considered a prime polynomial because the only thing we can factor out is a 1. So that's the first step. Factor out the GCF. After you do that, you determine how many terms your polynomial has. Does it have 2 terms, 4 terms, or 3 terms? Yes, I know these are out of order, but this is the order that we're going to learn them. If your polynomial has 2 terms, you could have one of 3 situations that can be factored further. You could have difference of squares, difference of cubes, or sum of cubes. So let's investigate those now. For 2 terms, difference of squares, well, difference means subtract, and sum means add. Okay, so for difference of squares, your 2 terms must both be perfect squares. If they are, you put the square root of each inside the parentheses and you put a plus and a minus, and it's really that simple. It's the easiest thing to factor, but the first thing most people forget, so be careful with those. Let's look at an example. This is a difference, this is a perfect square, and this is a perfect square, which means we have a difference of squares. So when we factor this, we're going to have 2 small parentheses. The square root of 4x squared is 2x. The square root of 9 is 3. And then we put a plus and a minus. All factored. The next one is a difference of cubes. Difference of cubes means we have a subtraction and 2 perfect cubes. Sum of cubes means we have addition with 2 perfect cubes. This is our formula for each of those. However, I think I'm just going to work a problem so you can see what it looks like. This is a difference. 8x cubed is the same thing as 2x all cubed. That means that 8x cubed is the cube of something. It is a perfect cube. And 1 is the same thing as 1 cubed. So whenever you have a sum or a difference of cubes, you're going to have a small set of parentheses and a large set of parentheses. First thing, take the cube root of each one. Well, the cube root of 8x cubed is 2x. The cube root of 1 is 1. We'll fill in the signs at the end of the problem. So now we square both of these that we got when we took the cube root, square both of those. So 2x all squared is 4x squared. So we have 4x squared, square the 1, we have that. 1 squared is just 1. In the middle, we're going to multiply these two together. So 2x times 1 is 2x. Now to fill in the signs, you use the acronym SOAP. Same, opposite, always positive. Same means the same sign as the original problem. Same, opposite sign than the original problem. This one is always positive. Same, opposite, always positive. Let's work the third one the same way. We know it's a sum of two cubes. The cube root of 8x cubed is 2x, and the cube root of 1 is 1. Square 2x, and we get 4x squared. Square the 1. Multiply 2x times 1. Same, opposite, always positive. These are how you factor two-term polynomials or binomials. I want you to notice there is no sum of squares. You cannot factor in the real number system a sum of squares. Our next type of polynomial has 4 terms. And when we have 4 terms, the first thing that we should try to do is factor by grouping. So what we're going to do is group together the first 2 and group together the last 2. In the first 2, we find our GCF. Our GCF in this case is 2x. Factor out that 2x. 2x factored out of 2x squared leaves us an x. And 2x factored out of 2x leaves us a 1. So this is like what we did on the first page, the GCF of the first 2 terms. Now find the GCF of the last 2 terms. Well, that's a positive 3. Factor out that 3. 3 factored out of 3x leaves us an x, and 3 factored out of 3 leaves us a 1. We're still grouping. This is like one of the problems we did on the first page. In these 2 pieces, the x plus 1 is the GCF, so factor out the x plus 1. If you factor out that, look at what happens. We're left with 2x plus 3. Or you can work this like we did on the first page. If you factor out the x plus 1 from this one, you're left with 2x. And if you factor the x plus 1 out of this one, you're left with 3. So this is completely factored at this point. Maybe you should pause the video and see if you can do the next 2 on your own. In this next problem, I'm going to group together the first 2 and the last 2. The first 2 have an x in common. If I factor out an x, I'm left with 5x minus 3. The last 2 have a positive 2 in common. If I factor a 2 out of 10x, I'm left with 5x. And if I factor a 2 out of a negative 6, I'm left with a negative 3. These have a 5x minus 3 in common. If I factor out the 5x minus 3, I'm left with x plus 2. Finally, we have this last one. We group together the first 2, group together the last 2. The first 2 have an x squared in common. If you factor an x squared out, you will be left with an x plus 3, right? X squared times x is x cubed. X squared times 3 is 3x squared. And the last 2, we have a negative 2 in common. If you factor a negative 2 out of a negative 2x, you're left with a positive x. If you factor a negative 2 out of a negative 6, you're left with a positive 3. Let's double check. Negative 2 times x is negative 2x. Negative 2 times 3 is negative 6. Now we factor out our common factor, which is x plus 3. If we take out that x plus 3, we're left with x squared minus 2. Now this actually isn't completely factored, but it is as factored as we need it to be at this point. Now we get to 3 terms. These may be the most important ones because they're the ones you'll see more often, I guess. So usually these are written in general form, which is ax squared plus bx plus c. A, b, and c are just coefficients of these variables. These are the steps that we're going to follow. So the very first thing we do is make sure it's written in the correct form. We have ax squared plus bx plus c. A is 1, b is 7, c is 6 in this case. Now notice the condition for this one. The condition is that a has to be 1. So this has to be a 1 here. A 1 and a 1. And for these three problems, that is the case. If a is 1, you just find factors of c. That's this one. So factors of 6 would be 1 times 6, 2 times 3, negative 1 times negative 6, or negative 2 times negative 3. Those are all the numbers that will multiply to give you a positive 6. After you have your list, find the pair that will add up to give you b. B is 7. So out of all of these, the only ones that add up to 7 are 1 and 6. Since this is an a equals 1 trinomial, we can put in our variable, our numbers 1 and 6. If this is addition, we put the sign in both of them. Now, how do we know if we factored that correctly? Because it didn't seem very intuitive to me. Well, let's check it. X times x is x squared. X times 6 is 6x. 1 times x is 1x. 1 times 6 is 6. Combine your like terms. 6x plus x is 7x. That is what we started with, so we factored it correctly. So what about the next one? We need factors of negative 45. So we have 1 times negative 45, or negative 1 times 45. Let's see, we have 3 times negative 15, and negative 3 times 15. We have 5 times negative 9, and negative 5 times 9. So these are the numbers that will multiply to give us a negative 45. Out of all of those, which one will add up to a positive 4? These two add up to a positive 4. So we put in our variable, our negative 5, and our positive 9, and we have it factored. Let's check this one. T times t is t squared. We have t times 9, that's 9t. Negative 5 times t is negative 5t. 9t minus 5t is 4t. And then negative 5 times 9 is negative 45. So that one also checks. So how about number 3? We need factors of negative 78 that add up to a negative 7. So we know that the bigger number has to be negative because we need a negative 7. So we can do 1 times negative 78. That's supposed to be an 8. So we have 78 divided by 2. So 2 times negative 39. We have 6 times negative 13. We can actually stop, because those two add up to a negative 7. So we put in our variable, our positive 6, and our negative 13. This one can be checked the same way as all of those other ones were checked. Finally, we get to a trinomial where a is not 1. Do you see how we have ax squared plus bx plus c? A is not 1 in either of these problems. So we must do something a little bit different when a is not 1. We use what's called the AC method. Now there are many ways to factor these trinomials, and Many teachers teach these many different ways. I'm going to stick to one way so that every time I work a problem, I'm going to work it the same way. I just don't want anyone getting confused. So the very first thing we have to do is multiply A and C. 5 times -6 is -30. Just like we did before, find factors of -30. So we have 1 times -30, -1 times 30. 2 times -15, -2 times 15. 3 times -10, -3 times 10. 5 times -6, -5 times 6. And just like before, we want the pair that adds up to B. Well, that's a +7. These two add up to a +7. Now we do not go straight to our parentheses this time. After you find the pair that adds up to B, you split the middle term into two terms using those two factors we just found. So instead of a 7x, we're going to have a -3x and a +10x. Those came from here, -3 and 10. If you were to add these, you would get a +7, right? So all we did was rewrite it using the numbers that we need. Now this is a 4-term polynomial. We factor by grouping. In the first two terms, we can factor out an x. We'll be left with 5x minus 3. In the last two terms, we can factor out a +2. We'll be left with a 5x minus 3. Let's just double check. X times 5x is 5x squared. X times -3 is -3x. 2 times 5x is 10x. And 2 times -3 is -6. So we're still grouping. Our GCF is 5x minus 3, and if we factor that out, we're left with x plus 2. Now let's check this one to see if we did it correctly. 5x times x is 5x squared, 5x times 2 is 10x, -3 times x is -3x, and -3 times 2 is -6. Combine your like terms. 10 minus 3 is a +7. This is what we started with, which means we worked it correctly. Finally, we get to number 2. A is not 1, so we do the AC method. 2 times 9 is 18. We need factors of 18. So we have 1 times 18, -1 times -18, 2 times 9, -2 times -9, 3 times 6, -3 times -6. Alright, we want the pair that adds up to a +9. That would be these two. Split 9x into a +3x and a +6x. Bring down everything else. In these two, we can factor out an x. We'll be left with 2x plus 3. These two, we can factor out a +3. We'll be left with 2x plus 3. 3 times 2x is 6x. 3 times 3 is 9. X times 2x is 2x squared, and x times 3 is 3x. So it does work. Our GCF is 2x plus 3. If you factor that out, you're left with x plus 3. Again, you can check the answer. 2x times x is 2x squared. 2x times 3 is 6x. 3 times x is 3x. 6x plus 3x is 9x. And then 3 times 3 is 9. So that one also checks.